Okay, what we got now is we're going to talk about the ceramic aluminum oxide plastic. But right before I get that, I want to show this little item here. And this item is my C60 C60 glue, my plastic weld. This is the glue that I use that is low resistivity, works really well, sets up and cures quickly, sets up in about a couple minutes or so. Okay, now what I'm going to do is go ahead and go back to this plastic. Now this aluminum plastic, this is one of the plastics that does have a metal in it, and it has the ceramic in it to toughen it, and boy is it tough stuff. It can take a good hammer smack. It's abrasion resistance, it's impact resistance, it's resistance to acids and bases, except for sulfuric, of course. It's plastic. It's highly conductive, and it's adjustable load. It has adjustable loading for toughness. The piece I have here is approximately 35% ceramic by loading, and it's tough stuff, as you can see here. Zoom in right here and give a little demo here of what's going on with that. And alright, sorry about this. Get this screw adjusted over, so that's what it's like this. Sorry. Okay, now what we have is this piece, and it is very shiny because I'm going to take a little bastard file to it. Here's a little file. And take this plastic. And as you can see, this stuff is tough. Only thing it's doing is polishing the surface. Okay, let's get to some conductivity tests. What I have here is I have a meters, and my meters are set up to read. This one's the load. It reads the voltage across the load and the resistance of the load. This is for looking at sine waves. This is for the current, and this is for the voltage applied. This basically confirms all of Ohm's law. And of course there's a blow dryer on top, which is probably freaking it out, but we're actually going to run a blow dryer through plastic. Now, what I want to do is show you what's inside the test box. Inside the test box, get a little bit more light. There you go. There's the test box. Now there's 3 light bulbs in there, so I can run 25, 60, and 40 watts. And here's the test station right here. This is where I put the piece, so I can run high current. Here is a current temperature controller that you can get on Amazon. And here's the safety switch to prevent any accidents. This is a lot of current here and power. So close this back up. I'm going to go ahead and get this placed in here. Now we can see the pieces in here. Volts is turned on. We're dropping 7 volts across it. Let's go ahead and bring this down. And you can see here that the voltage is slightly dropping, and there's a reason for that, but it's proprietary. I'm not going to say right now. And it doesn't have to do with diode stepping. It doesn't have to do with that at all. It's something unique. Here is just a DC line, and here's the current. We're running 1.085 amps. and I have a 14.42 volt supply. So this should be running right around 7 watts, which means it's getting hot. Previous shows that it's running now at about 150 degrees. And in about 30 seconds to a minute it'll be over boiling temperature, and it'll stabilize out once it, but it is a small piece for that much wattage. But the plastic's holding in there just fine. And the voltage is dropping, which means the current is slowly rising. This particular material likes heat. It drops in resistance. And here we have 1.121 amps.